Processors.
Hello, my name is Iulia Dumitru, and yes, I will be presenting Argus to you today. Argus was my bachelor's final project. That's why I started developing it, and it is highly inspired from Racket, especially from syntax parse, which is a library for parsing syntax and for writing macros, and resyntax, which is a framework for writing linting rules with refactoring suggestions, and it's based on syntax parse. I thought the ideas presented there are quite innovative and powerful, so I wanted to try to implement them in Julia. So that's what I did. Argus consists of two parts. The first is concerned with pattern matching and transforming syntax, and the second with writing linting rules, also with refactoring suggestions. All right, so the building blocks that everything sits on is really patterns, which imitate Julia syntax. And these patterns can contain pattern variables that bind to matching source nodes. These pattern variables are constrained by syntax classes, which represent syntactic categories. And on top of this, you can also have templates which use the bindings obtained from matching patterns, from pattern variables, to fill in the templates to obtain new code. New syntax nodes specifically. Argus uses syntax nodes and not express because syntax nodes from Julia Syntax are richer, they contain more information. All right, so let's look at some examples. For the first part, this is how you would define a simple pattern, which represents an assignment. So on the left-hand side, we have the pattern variable x, which is constrained by the syntax class identifier. And on the right-hand side, we have an anonymous pattern variable unconstrained, but by default constrained to xper. All right, and we can match this pattern against an actual assignment, and then we get a successful match, which is a binding set containing a binding from x, from the pattern variable x, to source node A. Identifier is an example of syntax class which is built into Argus. There are many others, such as literal, vector, function definition, stuff like that, but you can also define your own. Right, and in case of a failing match, then you get a match fail with an associated failure message. You can also compose patterns with OR, which has short-circuiting logical OR behavior. So the first pattern that matches, the first branch that matches, is the result of the entire pattern match for the OR. And similarly with AND, it's a short-circuiting logical AND behavior. It's also useful to represent a sequence of expressions, and that's what you can do with repetitions. So with ... here, it's not the splat operator, even though it looks like it. It's a repetition pattern form. But if you want to use the splat operator inside the pattern, then you can escape it using an escaping mechanism provided by Argus. And this is how you would define a new syntax class. This example shows the syntax class for integer literals. The body of a syntax class consists of one or more patterns, and the match result of a syntax class match is the result of the first pattern that matches. In this case, we only have one pattern, which represents a literal, and we are asserting that whatever is bound to that literal during the pattern match needs to be an integer, or otherwise the matching would fail. And we can use the newly defined syntax class the same way as we would use any other predefined syntax class inside a pattern that we define. All right, so that's the foundation for pattern matching. And Argus also provides templates for transforming a piece of syntax into another piece of syntax, but this is very rudimentary. I just recently implemented this feature, so it's not much, but still it works. So you can define a template, which is essentially code with holes, and you can fill those holes with bindings you obtain from a pattern match. This example shows a very rudimentary implementation of show. So we match an expression on the first line here. We obtain the bindings. We define a template, which is a call to print line followed by the expression itself. We expand the template using the bindings obtained from the pattern match. Then we turn the resulting syntax node into an expr, and we evaluate that, and we obtain what we would expect from a show. That concludes the first part of Argus, and the second part consists of DSL for writing linting rules. A rule consists of a description, a pattern, and optionally a template if you want it to be a refactoring rule. And the main difference between a pattern match and a rule match is that a rule match searches for all occurrences of a pattern inside source code and returns all the associated match results with optionally their associated refactorings. So to conclude, Argus can be used by language developers. I think it is quite an expressive and flexible tool for manipulating syntax and maybe eventually for writing macros, but it needs some work for that. Or by language users who want to write linting rules for their Julia programs. There is a lot of room for improvement and a lot still to learn from Racket and from syntax parse. A lot of research has gone into that, so there's still much to learn from there. Suggestions and contributions are, of course, more than welcome, and maybe during this hackathon, I might be working on a macro for writing macros to make the templating more useful in Argus. So if anybody wants to join, I'll be happy to collaborate. Thank you.
Do you have any questions?
Yeah, very cool talk. Really, I really like it. I like. What about performances? Do you know, like, does it scale with the amount of code?
It is currently very slow because no effort has gone into optimization whatsoever, but I think it has potential. So if somebody, or myself or somebody else, has the time and wants to get into optimizing, there's many aspects of it, especially during pattern matching, that can be optimized.
Another question? And the last one.
Thank you. Very interesting topic. Did you find the design of moving the syntax templates to Julia? Did you find any challenges that weren't present perhaps for S-expression-based language like Racket? Like, have there been any pieces of that templating system that maybe were more difficult with the Julia syntax versus Racket?
Right, so for templating, I haven't put in that much effort into it, but for pattern matching, yes, there were some differences, some challenges. The main one is that there is no one-to-one translation from an expr to a syntax node, and that's what I face the most difficulties with. So yeah, that's the main one.